Hi, everyone. My name is Almog. I'm heading the product strategy team here at DriveNets. And what we're doing here in DriveNets is building networks like hyperscale clouds. So in a nutshell, what does it mean? And why do we think that this is disruptive? Or why does the industry think that this is disruptive? How is this creating network transformation? And above all, why did AT&T vote to take DriveNets into their core networks? All of that is going to be in this within this session. So with this brief intro, let's get started. Okay. So the first challenge we are trying to solve in terms of network challenges is this curve that you see here. What we're looking at is the expectancy of traffic to grow, and it's already started and expected to boom. And then there are two additional curves. One is indicating the cost per bit, and one is indicating the revenue per bit. Now, both of them are going down, but at a different slope. And the thing is, or the paradox here, is that these companies, service providers who are essentially selling bandwidth, are in a situation that the more bandwidth they sell, the less revenue they make. Again, because the cost that they are paying per bit is, even though it's reducing, the revenue that they are achieving from it is reducing in a faster pace. So again, more bandwidth is creating that paradox for the service providers that they are less beneficiary out of, or as a result of it. Now, the reason for this to happen is because service providers are offering the platform or the transport, but above this, there is a layer of services, also known as over-the-top services. Somebody who is providing these services is making the main revenue out of the increasing internet traffic and not the service provider. This is the biggest challenge that service providers are currently facing. Now, what we're looking at now is a traditional network model. How traditional? This is what they teach you in school. It's that old, and it's being kept in that scenario, even though we are looking or coming to the closing part of 2 decades of trying to change that network sketch. And the elements who are holding this back are the actual vendors who are providing the equipment, which is essentially constructing these networks, or as they say, building the internet. However, the service providers who are, again, providing this as a service are becoming locked in with that specific, with a specific vendor and not holding that capacity or the capability to actually control their network, or I should say control their destiny as well. Now, this situation has occurred before. That's not the first time. If we take back perhaps a couple of decades ago and looking into data center, this is how data centers or server farms used to behave like. We had specific servers dedicated for a specific application. The server was customized for that specific application. In most cases, it was utilized to a very small percentage because it was calculated to the peak capacity or the max potential capacity of that application. There's always been another redundancy server to serve that same application. And eventually, the utilization level and the amount of expense of the data center in order to sustain more applications, or the time it took to raise another application, was very, very long. This is where cloud came in. And what cloud did is take these ruggedized or hardware-based servers and virtualize them, enabling several applications to run on the same physical machine. Today, we are looking at this situation or this scenario as something which is totally trivial, but 2 decades back, this was perceived as a dream, futuristic dream. And this is exactly what DriveNets is doing, but this time not for the compute or the storage, but to the network side of things, and taking that network, turning it into some sort of a cloud. We will see in the next slides how is this actually shaping up. From a technological perspective, what DriveNets is doing is disaggregation. Now, disaggregation comes in various layers, and there are many indications of disaggregation. We'll take it from the bottom up. So first and foremost, disaggregating hardware from software. We have seen this. This is supported by all sorts of standardization bodies like OCP or TIP. That's, I call it first layer. And then the second thing that, and this is very common, a lot of vendors are doing this and have been doing this for close to a decade already. The second tier is about disaggregating the chassis architecture itself. So taking the chassis and breaking it into its basic elements. This is something that DriveNets is doing. This is something that has also been contributed to the OCP known as DDC, Distributed Disaggregated Chassis. This was contributed by AT&T, and it's the basic element of what's currently deployed in their core network. The third level of disaggregation is what we call a cloud native software. The software by itself is also distributed into sub-elements. Each element is carried via a container and is a standalone or a self-sufficient element within the control plane or the service plane, which is running throughout the network. And then at the end of the day, the fourth tier is having all of these various components eventually behave as one, as a single solution. If it's a variety or a spray of building blocks that are the outcome of breaking up the borderline of a chassis, all of them combined need to still behave like a normal standard router from the external interfaces and all the basic elements containerized of the modular network operating system still need to behave like a network operating system and not like an array of independent applications. The one thing which is important to note is that eventually it's an open model. DriveNet is providing the software piece of the network cloud, or what has been contributed to the OCP as a DDC. The hardware is coming from ODM companies. The implementation is based on specs, which are again contributed into the OCP. So from the perspective of the service provider, he can take the best of both worlds. He can pick whatever software he chooses that supports this model, and whatever type of hardware that he chooses, again, that supports this model, make that mix and match, and then end up with a type of a service where it has an array of resources, same as what you would see in a server farm, an array of resources. In this case, it's forwarding machines, servers, switches, routers, and on top of that, an abstraction layer, a software piece that takes all of these resources and utilizes them as if they are resources of a cloud. But again, in this case, it's not compute or storage resources, but network resources. So moving into a little bit more on the details, what is this distributed, disaggregated chassis? Let's look at a standard chassis. What you see on the left-hand side, it's a monolithic box inside an enclosure, a steel enclosure. It has line cards and then fabric cards and control cards. These are the three basic elements. We just tore it apart. We took out the box and we use every such element as a standalone. So we have standalone white boxes known as NCP, which are acting as what would a line card do inside the chassis. The second tier is what we call NCF. That's the actual fabric. Again, the fabric engine or the fabric element, which we took out of the chassis, and then control elements. What was previously control cards, again inside the chassis. Now there are standalone servers holding an instance of the control plane of the distributed architecture. Again, this control plane doesn't have to reside on an x86, dedicated x86. It's a modular piece. It's built with containerized functions, and it can run on a dedicated machine. It can run within a VM. It could run as an instance within one of the existing elements, the existing white boxes of the solution. And then once again, on top of all of this, there is an abstraction layer that turns all of these elements into a single unified so-called router, even though what we're building is essentially not a router, but a routing service or a platform that provides routing services. All of this is what we call network cloud. Network cloud consists of the operating system itself, DNOS, as it's scattered inside of containers and throughout the entire cluster. The cluster itself, which is comprised of white boxes coming from ODM companies. We do not manufacture these boxes. You do not even, we do not even sell these boxes. You are eligible to acquire these from the ODM companies themselves. And there are a bunch of these that we are already working with, and of course, many which are already in deployment. And then on top of this, we have an orchestrator known as DNOR, the DriveNets network orchestrator, establishing the look and feel of a cloud in terms of everything to do with resources, in terms of how does a network cloud integrate itself or interface itself to other network clouds in the network, and how all of this is being interpreted in terms of providing a service or allowing a service to traverse the network. As I noted before, this essentially builds out routing as a type of a service. That was, I'd say, the first application that we actually implemented. But routing is a service. It's not everything that this network cloud is capable of doing. It's one service out of many or any that can traverse this kind of a network. Now, I've showed you before how does the traditional network look like. You can see it again here on the top side of the screen. On the bottom side, you will see how does a network look like when network cloud comes into play, or when you're utilizing the disaggregated model. Wherever you had a dedicated machine for aggregation, for distribution, for edge, for peering, for core, and each of these machines is a different form, a different shape, maybe even a different vendor running a different operating system as well. There are a lot of, there's a high level of variance between these boxes. Eventually, when you build your network using network cloud, what you have are two building blocks, the NCP and the NCF, as I noted before, and they can build every element within the network, starting from first level of aggregation and all the way up to the core. It's just a matter of the amount of boxes and the flavor of the containers you want to run, or the flavor of services that you want to run within each of these use cases, or I should even say network locations. One thing that comes into mind, obviously, is one unified pool of spare devices that you can fulfill every type of need throughout the entire network, so you don't need to keep a whole variety of boxes. And second is because in many of these locations, physically, these devices are co-located, converging between different layers of the network or tiers of aggregation becomes trivial. The same cluster can be fulfilling a core use case or an edge use case or an aggregation use case. And as long as these are co-located, why not do it on the same cluster? From a flexibility standpoint, every port in the cluster can be utilized for every service. So there are essentially no limitations in terms of what this network cloud can do in terms of fulfilling a variety of services. Zooming out of this is how we perceive a network, or the network of the future being run. Obviously, it doesn't have to be all network cloud. Network cloud is perfectly capable, and it's fully standardized on any external routing interface. So having a network which is a hybrid that consists traditional routers with network cloud is obviously a possibility, but the end in mind is having a mutual platform that is the network, essentially, and it can run all sorts of services or any type of services from end to end. Eventually, when we say portfolio, it's not a portfolio of products, because all you see here are two types of boxes, as I noted at the beginning, but the portfolio is actually the use cases or the types of services that eventually the network cloud or DriveNets can provide to our customers. Now, network clouds network cloud is, as I noted, a service platform. What you see here is kind of an illustration of routing being one of these services which is traversed throughout the network. And due to the architecture, the microservice architecture of the operating system, any type of a service can be then implemented into a container, run as a container within the boundaries of the operating system, and effectively run anywhere throughout the network and utilize the resources of the network elements. So if you're talking about bandwidth, or if you're talking about entries on your forwarding database, these are all eventually resources. And as long as the service which is needed to be run on the network is granted proper access to these resources and direct access to these resources, then any sort of forwarding capacity can be then offloaded to be run on dedicated hardware. This is how you gain scale. This is how you gain latency. This is how you gain anything to do with network performance. And at the end of the day, this is why network cloud, when it comes to brute force performance, scale, capacity, bandwidth, and so on, can essentially reach numbers which are bigger than any other existing router worldwide. First off, we took out the boundaries, the physical boundaries of the router, and therefore we are able to achieve these results. Now, network cloud is primarily introducing a new model of how the network is being charged for, or how much does a network cost. This is our, or perhaps a headline from our TCO analysis, which was done by the ACG group. And what we see is that there is a total cost of ownership reduction of roughly 50% as a result of using network cloud. Now, this is coming from a variety of aspects, not just one. First, obviously, is the transition from a dedicated a monolithic, huge chassis coming from an incumbent vendor who is supercharging for his equipment versus an ODM white box, which is originally or traditionally sold in a cost plus some margin model. That's one aspect of it. But the software also is being provided now, in this case, by DriveNets as a flat fee, recurring annual payment that needs to be paid to DriveNets, regardless from the size of the network. So the network can grow as traffic explodes and you add more white boxes, which do not cost that much, but what you're paying on the service level, what you're paying on the software stays as a flat fee. In addition to this, everything to do with setting up of a network, operating of the network, because the model is abstracted and distributed as network cloud is, introducing automatic tools and automatic methods for bringing up the network for items such as zero touch provisioning, bringing up boxes into a cluster, a new cluster, or replacing a box within a cluster, running a software upgrade throughout the cluster or throughout the network, are all automatic functions which are being enabled by this DNOR as an overall orchestrator for the entire network. What you see in this graph is again an illustration of how the new economic model eventually work, starting from the bottom up. Everything to do with the software licenses per a specific application, again, is a flat fee. It doesn't change throughout the lifetime of the network, pending, of course, the contract that we sign with a specific customer. On top of that, we are seeing the costs of the hardware itself, the white boxes. Again, this is a cost plus model. So adding more boxes to the network doesn't cause a boom or a boost of the overall expenses, but it's kind of a gradual slope of an increase. And then capacity of the network obviously can grow dramatically. This is not controlled by the operator, but by the market. But because the cost increase of the network itself are so moderate as the network grows, this is what creates that beneficiary margin that the service provider has been seeking for that many years. So in kind of an attempt to conclude some achievements of DriveNets up until now. Obviously, you've all heard about the AT&T announcement. AT&T are running the DriveNets solution, the distributed, disaggregated chassis, along or fulfilling a Broadcom ASICs inside and using boxes from UFI space. This has all been in the AT&T announcement, and this is already running in the AT&T core after, you can imagine, many months of rigorous testing. The industry is carrying complete consensus in terms of the model itself, disaggregation as a whole, and openness of the router. The industry, from the service provider's perspective, has been trying to reach that level of introducing cloud functions or capabilities or know-how or benefits into the network, and this is exactly what DriveNets is doing. The ecosystem is there. I mentioned Broadcom and UFI space, but like I said, there are many other ODM companies which are already as part of this ecosystem. And it's not only AT&T. AT&T perhaps are the first to come out public, but there are over 20 tier ones or large tier two service providers worldwide, including some hyperscalers, which are already engaged with us in certain steps of the process. So we expect to see more of such announcements coming in the upcoming months. And this is pretty much it from the DriveNet side. Thank you very much for staying put all the way through to the end. I believe we will have some questions in a chat session in parallel to this. So again, thank you for listening. Again, Almog, DriveNets, appreciate your time.